Maris Baltbergs will be the one to open this conference. Maris is a chairman of the board of Altas IT, and he's the one to say, now let's begin. Maris, welcome to the stage.
Hello, ladies and gentlemen. As you can hear, I have tuned in with my stage voice. So try to understand, and if you have any questions on my speech later on, especially on the tasks, come over and ask. So as Valdis just said, my name is Maris Baltbergs. And the main thing is that I believe in a future of security through technology. That is one of the reasons why I am here, and I believe that that is also the reason why most of you are here. Today there will be a lot of seriousness, because today's topic is very serious, and judging by your faces, you are all professionals in seriousness. So I have one suggestion: loosen up, smile. The most important thing about smile and being relaxed is we can preserve and get more information and remember it way much easier than when we are all stressed up. So today there will be a lot of information for you to remember, and a lot of things that you might want to share tomorrow with your colleagues, with friends. As we see day to day, the role of security and safety, both personal and commercial, just keeps growing, and the stakes are rising. I organized this summit as a logical step and as a way to join our forces against disturbing happenings around us. This event marks a turning point in our industry, at least if all of us let it to be such an event. Well, on the outset, it might seem that this is just another conference. Yet, in fact, this day that will initiate change in our society. At least it can be, as I said, if you let it to be. Today we will go deeper in topics of international security, artificial intelligence, thermal technology, and the role of technology in fighting cybercrime. And of course, there will be other powerful topics. We are all experts in field of security, and the positive future, to some extent, depends on all of us. It depends on our passion and curiosity to know more. It depends on us constantly asking questions. What is next? How can we do it better, faster, more efficiently? It depends on us pushing our limits for the sake of common good. It depends on us constantly learning and focusing on our vision. Today we have an impressive lineup of speakers. Lecturers for today's event are highly renowned experts and have been chosen intentionally and for a reason. The reason is very simple. This is just value that these people can bring to us. Therefore, I encourage you to listen closely to today's speakers and read, or should I say listen, in between the lines. And think of situations in life where you can put this information to actual use. The change I mentioned is about our mindset and the way we perceive the world. We all know how important this topic is, yet we tend to have a narrow focus on it. We are more likely to focus on a very close circle, although the safety and security of our close circle largely depends on well-being of much wider circle. Our intention with this summit is to start to change, or would I say give it a new, better push, to widen our perspective and notice how seemingly distant events and progressive solutions are in fact very relevant and might affect our lives. The future needs us to be proactive. It needs us to be visionaries. So most of us gathered here are driven by technical and analytical thinking. Yet recent global events have reminded us that security goes much deeper than technical equipment and statistics. It touches lives of people in so many ways. It concerns emotional aspects and the quality of our lives. This expands today's topic and makes it so much more important. I actually see some people nodding, so I'm sure you know what I mean. If I could ask just one thing of you today, that would be to pin down 4 things. 4 things that you didn't know before today, or that you know would change the world around us. Write those things down if you need, and go about your day tomorrow and share these things with other people. In the end, I think that would benefit all of this situation to them and to us, to make a better and safer tomorrow. Basically, that is why my company, Altas IT, and this is actually what is my company, Altas IT, all about. We bring the top-notch technology to Baltic states. We do it hand in hand with our partners. And I see many of you are here. We do it by sharing everything that we know about the technology and security, of course. We do it because we think it's not enough that we are the smart guys. We think the more security technology experts will be there, the better. The conference is a huge step in that direction. But knowledge, information, and contacts are nothing without proper execution. And this is where our partners come in. As I see it, there are 2 ways you can take. Firstly, become an exceptional technology expert and the highest top expert in your company. For that, there is just one question to ask yourself. What did you do today for sake of becoming a top security expert? Well, it's pretty obvious about today because you are here, right? Secondly, become an implementer. Having smart people around is great, but we also need some action people. If you feel that power within you, then I have another question for you. What is the first step that you have to take to make that happen? Whichever of these 2 steps you take, it brings us to where we all want to be, in a safer tomorrow. Well, that would be all of my inspirational speech. I'll give the floor to our prominent speakers now. All this is for you. Enjoy it, take the best of it, and mainly remember, pin down 4 things that you will share tomorrow to make the world safer. Thank you very much.
Thank you, Maris. And thank you for this heroic speech, knowing what you're fighting now. So as Maris just said, let's loosen up and let's get to work. And at the end, I would love really to hear from you those 4 things you chose from today to use and make your work better and help your clients and yourself better with security. Our next speaker, Dmitry, is from Latvia but currently works in Prague. And he's a senior security software engineer at Microsoft. But in total, Dmitry has about 10 years of experience in the field of information security. And he will be speaking about artificial intelligence. And the question is, can artificial intelligence help security professionals improve the operations? And especially if we talk about disinformation. But that will come the next question. Now, this will begin about most common mistakes that lead to failures in the application of artificial intelligence. So we all have been there because we are most commonly targeted people in the industry. That's why the more experience you have, the more mistakes you have made. And let's see what Dmitry has to tell about that. Please welcome Microsoft Senior Security Software Engineer, Dmitry Trizna. Dmitry?
Hey everyone. Today we will talk about artificial intelligence applicability for security operations, basically for defensive needs, how we can use AI to detect stuff, right? Roadmap is as follows. We first of all focus on maybe some general AI improvements over the last years. Then with the side note to cybersecurity, what are mistakes, how to avoid them, what works. Specifically of those techniques that works, we'll cover statistical methods, traditional machine learning techniques, and deep learning. Brief bio, why you should trust me in this topic. Like started here, like about, long ago in Riga, worked in Latvia, like defending industrial setting, then worked in one of the, let's say, best teams in Baltics of red teaming, like evolution from an offensive point of view. Then moved to Prague, back to defensive postures and applied ML techniques for defensive needs. Now working in Microsoft as like defending cloud backend with AI. I have a good track of academic experience, like 2 master degrees, because artificial intelligence is the field that is powered by scientific method. And you should be able to read papers, even write them. That's what we do as well. And a bunch of certificates like OSCP, SANS, Stanford ones, and briefings on like top venues like Black Hat, DEF CON this last year. So jumping in, let's first of all, a bit of taxonomy. What is ML, what is AI? Basically, machine learning is a field of study that includes lots of algorithms. Deep learning, which is a fancy word for neural networks, is one of them, but there are many other models that live under this hood. And AI is this umbrella term for ML, for machine learning, but for other fields as well, like ethics. Do we give rights to robots, right? Biases within the models, so it does not, include sexism or something like that within them. Alignment problems. How do we build AI so it helps humanity, not destroys it? If we task a really powerful AI to build a paper clips, it can build paper clips so good that it doesn't care about us, right? And many things. But for security, we really can avoid this branch of discussions, and we can consider that for security, AI is basically machine learning, which are algorithms. AI just sells better, that people use artificial intelligence more often, but basically those are algorithms, and algorithms are just software. So it's not a magic something that does a lot of stuff. It's just a software that works, and we code it and we task it to do something. How AI development looks like there are promising results from time to time. In use, we see something. This yields some expectations and forecasts, which produces some funding, and more funding would result in more promising results. In security, we unfortunately often see expectations or forecasts too sales-worthy, right? Vendors want to sell their product, and as a result, like they are speculative. As a result, this additional funding doesn't always lead to promising results. That's true. And in fact, that led to so-called AI winter back in 70s and 90s of last century, when AI research was almost completely halted. And as a result, there is this pendulum of public society opinion on AI, where at one degree, public thinks that AI will solve everything, all problems, replace security engineers, replace humans, and another like swing of pendulum, people are saying AI is a fraud, and like, where are all the self-driving cars, right? They are not here, and why? But in truth, it's somewhere in between. Let's see whether like AI is indeed like a fraud in 2022. Generative AI in computer vision is so powerful. Last like 4 months really was such a huge boost for it. We can now generate just from a prompt an image, basically. AI now wins and like art competitions. It's like surpasses human artists already. This image was generated by AI that won that NYT competition they mentioned. And there are free models. Every one of you can use them. Stable Diffusion, download it, play with it. It will generate you anything you ask. And this reveals new fields of security as well. For instance, there are red teaming like of AI algorithms itself, because if you can generate anything, you can generate something like inappropriate, right? And in fact, they proved that, for example, Stable Diffusion is good on defending some nudity or sexual content, but when it comes to violence, it's easy to generate violent images that can be used in disinformation or something. Like, you give it more resources, the more realistic it gets, and it's wild. Like, in next 5 years, we will see a lot of applications of this, and this will transform how many things happen in our lives. Similar thing with the language models. We see AI able to reason, to use text on the level of human. Like, basically, Turing test is passed. With the communicating by only textual way, you will not distinguish whether this is human or AI anymore. They are able to reason about death. They pursue experts that they are sentient. In fact, I advise you to read, for example, this article. It really covers extensive discussion of one Google engineer with their model. And after that, they suspended him because this raises some easy questions for public to give rights to that model or not. And those models are public as well. T5, distributed by Hugging Face, download it. It contains English, like all language within itself, and it can do something like that. Implications on disinformation is huge. But what we see in information security, like data science say they detect anomalies, but as a result, we see something like this, like huge amount of, red flags, and this doesn't help security engineers at all when you see like thousands of them. And the situation is something like this in 2022. Like, AI in CV and NLP is huge, but in information security, it's kind of it's not there yet. It's not mind-blowing, right? And what went wrong? What like sort of are at least things that hold off AI in security? The problem is that there is a gap between like information security as a field and data science as a field. We have this applicability problem. Why is that? It's because usage of AI requires bilingual knowledge. Like, researchers in the domain of NLP and computer vision, they know their subject of study perfectly. Everyone knows how to speak at least one language, and everyone knows how to see, right? And that's because application of AI on those domains is sort of intuitive for them. But when we speak about information security, that's the problem. Like, people who apply AI or who really deeply understand it don't know security field. People who know security field don't really know AI deeply, and that's the problem. And by by my work and trying to maybe lower this gap between information and data science field. And in the following slides, I will show how you security folks can use, like I am security like specialist as well. I'm started in security, but slowly digging into AI. And the things we need is easier applications of AI for security people. And for that, let's unwrap what is security, what is detection engineering. We will speak about detection needs. By building detections, we try to answer what is bad, right? Like this command. Who in this room knows what is Mimikatz? Can you raise your hand? Okay, not many. I expected more because Mimikatz is, I don't know, it's the most known, not let's say malware, but a tool that malware uses. And on the bottom is the legit command. Like every Windows system that boots up, like executes multiple of these processes. So security is easy, right? We just detect what is bad and profit. Like it's easy, we solved it. Unfortunately, no. There are a huge amount of gray area that we really don't know. Is it bad? Is it good? In some circumstances, it is bad. In some circumstances, this is not bad. So really, what we do is not trying to answer what is bad, but we were trying to answer what is not representative for your environment. That's the essence of security. What is yours is good. What's unusual for you, this is bad. And or at least it's worth interest of your security department. And in this case, specifically, ML can help to cover this gray area. This gray area, in fact, that's what's used by adversaries today, like light breaches, lapsus activity against T-Mobile, Okta, and many other companies, including Microsoft, by the way. Uber breach, basically a few weeks ago, they all exploited those gray areas. MFA bypass. Uber done this by spawning user with the many VPN second factor authentication requests, and user finally accepted that because he got annoyed with notifications. Internal threats, lapsus used internal personal in mobile networks to spoof the second factor messages. And those areas we can cover with ML. One example, for instance, legit activity, kernel 32 DLL loads by system. It is like main interface for applications to talk with the Windows kernel. And many applications do this. Like we can capture this event by system ID 7. It records library load events. And in 5 weeks, we have 30 million hits. If we try to filter legitimate applications that do this, we still, like after a dozen examples, we still have 70 hits in 5 weeks. And that's not the way to go. That's not how security heuristics are built. You cannot really filter your baseline just with the if-else's, like we done with Mimikatz. And for that, we really need ML, or at least something more sophisticated. You might not need really ML at all. First of all, focus on these statistical analysis techniques that are possible. For example, in fact, statistics really is not far away from ML. ML really borrows 70 or 80% of their techniques from statistical analysis, just add some iterative logic on top. And we have a lot of similar statistical patterns in our environments. All of your networks have this distribution of data within. For example, I discussed this in this topic. We don't have time to dig deeply in that, but if you're interested in more, I definitely encourage you to take a look on this article. And it basically is count-based statistics about like any type of data you have. And that's what we can use for kernel 32 DLL as well. We take those events, we count which processes use it, and we only investigate processes that loaded this library less than 5 times, for example, in a week or in a day. It depends on your environment. And you will catch rare stuff, no ML needed. You will catch rare that is of interest for your security department. That's it. Profit, good security heuristic. But yeah, there are cases when those like manual methods, when you define some rule or some statistical methods like this fail. And in that case, ML can help. And if you use ML, we go for deep learning. do you remember? It's that branch under ML umbrella that does the neural networks, because neural networks are cool. We need to go there right away. Please, no. Neural networks is a pitfall. If you go there right away, you will lose a lot of time. You will lose a lot of human resources. Take a look on conventional ML techniques. And if you are, for example, that's the thing I'm trying to emphasize. Not obligatory you implement them yourself, but when vendors come to talk to you, use these logics, ask them for statistical methods, ask them for conventional ML techniques, because those work better usually. This is, for example, meta-analysis that does analysis of many algorithmic families, and it showed that, for example, conventional technique like XGBoost, will not focus in detail what it is, but I will show you, in fact, performs, does the thing much faster with higher accuracies than many deep architectures. And the same applies to anomaly detection. There are neural network architectures to detect anomalies, like autoencoders and others, but something like ensemble of isolation forest, which does relatively simple logic, detects outliers much faster, at least. And in many cases, it solves your problems, especially in security domain. And but here the main challenge is not what model to use, but for you to take your data, which is like system logging or something like that, and transform it into a numerical array. Some vendors help to do this. They provide already to use pipelines. Like if you use CMs, some of them include this, others not, and you need to do it yourself. And for that, another thing that I see is a huge problem for industry that I covered as well. Definitely, if you're interested in this aspect, we will not focus here, but go and step-by-step instruction is in this article. Basically, we take a command of, for example, in that case, I used Linux commands, and we encode it in numerical array just by step-by-step, how to do this with code samples and everything. And it's not that hard. It's actually just a thing that you need to learn one time, and that's it. Another problem when you apply ML on your data, I see that people ask incorrect questions to the models. First of all, questions are too broad. We ask give me a anomalous process name, or give me a rare connection. And those are that's why we see this picture. Data science don't know that anomalous in your network doesn't mean bad. Everything happens sometimes for the first time. Your network, every one of your network has something anomalous today, and it's not malicious, it's benign. But it will be flagged by such solutions. Therefore, your questions to, for example, anomaly detection should be around specific technique, TTP it's called in security. For example, give me anomalous Python invocations. Give me anomalous SSH logins to specific set of family, domain controllers or jump hosts, in that case SSH, RDP to domain controllers. And this gives the desired picture. This gives a few anomalies only. In fact, this one is a visualization of Python processes, and one of them is malicious. And here, if I have a moment for, basically, maybe any one of you know what any of these commands do. They basically do the same, but in different form. Maybe you can raise a hand if you recognize them. Yeah, cool, thank you. And those are the reverse shell commands that you can execute on a compromised host, and it will throw you a full control over the host to your location. In this case, for example, 10.0.0.1. And we can, it's often used by adversaries and anyone in your network, and we can try to take a look on demo how this works. It's here. So basically, this is a code, a notebook that does this, but we will not focus through all code details, but basically, we will take only 4 features for now, and we see that it gives a good metrics and with some false positive rate. For example, one false sample out of, 1,000 samples, it gives something like 96% of detection rate by just using those 4 features, in a command. And this is a command we basically feed into a method, and we see the probability of badness is 97%. And here we just take random choice of 10 commands from our test set. Test set is a set that wasn't used for training a model, and we see that some commands that are like weird, given like 26% of probability, and this one is legitimate command, but it's like 26%, but bad commands are like 97 and something. We can increase this amount what machine learning takes into account. For instance, for 500, let's say, and retrain the network. Let's take a look how long it takes. It's basically training on 200,000 samples. And it really takes, 10 seconds. 10 seconds to train this conventional algorithm. Here we see a perfect curve that it detects basically all the bad commands in our test set. And here we see this command was, still 97%, but if we analyze the choices, we now see much more confidence, like 97 in this per command, which was 69, and this it's now like much more confident that this is a good command rather than bad. And now it uses all those features from the command line, and there is no way you can do this manually. You cannot task your logic to analyze all this. And DML is like perfect for this, 10 seconds. And you can do this with the vendors, you can do this manually, and basically any string can be used. For instance, here, if we task to take just basic bash minus L, which is legit command, it will say that this is like a good command. So it's pretty robust logic, and for that, DML is really a solution. When to consider a deep learning? Again, deep learning are neural networks. When you want to go through this from conventional techniques to really fancy stuff. If you have pre-trained networks, NLP and computer vision relay direction when they ship the pre-trained network, that's what I shared you. You can download them and use, for instance, NLP for chatbots or disinformation. In fact, that's the thing which it will be used a lot in next years. Computer vision for security needs, you can do, for example, object detection on CCTV streams. You can detect people in some forbidden areas, and if someone appears there, you can send an email or a message in a Slack or something like that. Or you can train your own network, but in that case, you need really, let's say, a lot of data and a bilingual, at least, if not a person who knows both fields, but then a team. When within the same team, you have a security guy and AI guy. If those are separate teams, for example, security department and data science department, they really have it doesn't work well. Usually, it's better to put different people with different background in the same team. People would say that computing resources as well are important. I'd say this is not a huge problem usually. Like medium-sized businesses can afford to train the networks. The first two bullets are more significant. Example where deep learning works is, for example, PE classification for malware needs when we take an exe files, and in that case, basically, that's what I presented in the Black Hat as well. This scientific, let's say, way how we analyze the P samples. This needs a deep learning. Here we can't go with traditional methods. Conclusions. AI is a software. It's a tool. It's not a magic stuff that substitute humans. It's a tool that you need to use, like any other tool you use in your work. Uses as extension to your techniques, not substitution. It will not substitute you. I like to think about security as a Swiss cheese model. When we really cannot solve security. It's not solvable stuff, but we reduce risks by doing our work. And every new, let's say, day that you contribute to your stuff, it reduces risks for adversaries to compromise your network. You start with signature rules. They should persist. It's a way to detect the really bad stuff, which we know is bad. And then we add additional layers of, I don't know, logics on top, and those include only like technical. There are lots of procedural methods to add, like least security architecture of network, and you layer them up to reduce the risk of compromise. Do not use ML when not needed. Like this, many want to use it because it's fancy, it's hypey topic. Think twice before you do this. It can take a lot of resources, but those who will master ML really will have an advantage against those adversaries, against the threat that we face from government funded groups that are threatening our region, and we really need ML for that. We need to distinguish what is like this gray area. Yeah, that's it. If we have a time for questions, then we can do it. You can grab a Medium link to if you're interested in those few articles that I mentioned, or follow on Twitter. Yeah.
Thank you, Dmitry. Thank you. Like I said, it will be a hard work. So, in case you dare to ask questions of Dmitry, just raise your hand, and we'll be happy to help you. Yes, please take photo if needed. AI nowadays, at least in Europe, are not somehow stopped by technology. Technology is there. But liability questions, it's always about regulations. Where are we standing here in security field on liability and responsibility on technology and results?
Yeah, good question. Liability is really, for example, a huge problem for self-driving cars. We have like algorithms that do it like almost perfectly, but a few cases still like pushes it down. Even though that like when human is driving, there are more fatalities on the roads than in AI driven stuff. In security, it is less of a problem. I'd say more like mostly you implement this in-house. When you go and try to sell something, you might think twice whether this affects your data somehow, and people are not willing to give their data, for example, to train a model. But when you build it in-house, or like CM vendor provides you an algorithmic pipeline and you build it on your data, I would say this is not like a focus right now. The focus right now is this gap between the fields, and that people in security are sort of afraid of AI and really don't know how to use it, because we know how to use Linuxes, we know how to use many stuff that we use every day. AI is, in fact, will be one of them in 5 years, but today people are still sort of afraid.
Do people used to trust it more and more, or it's the insecurity is still there?
Let's say there is less skepticism in last years. It was hugely skeptical, like amount of people in InfoSec like 5 years ago, but today people see that this indeed helps them and can really solve their problems if applied correctly. So, yeah, like let's say people are more trusting, but it's still rolling. Yeah.
Thank you. Yeah. Thank you, Dmitry. Round of applause.